Hi, thanks for coming to the San Francisco PHP Meetup. Tonight our talk is going to be on Zend Framework 2, PHP development in the 21st century. Speaking tonight is Nick Calugar and Jon Tai from IGN. They both contribute quite a bit of stuff to Zend and work with it day in and day out. So they, I don't know if you remember, they were here. Nick gave a talk a couple months back, and this is kind of a continuation of that from everybody's interest in Zend Framework. We're going to be taking January off this year. Just historically, January's kind of been a dead month and we get like 10 people showing up. So we're just going to go ahead and wait till February. In February, Orchestra.io and Engine Yard are going to come out. They're going to be talking about working with different PHP extensions and with the new pair repository that is eventually going to happen. So that'll be happening. Our sponsors tonight is IGN Entertainment, us here. We provided the food, facilities, Nick and Jon's time, my time for organizing the event. We don't have much of a speaker lineup for next year, so if you have any suggestions, send me an email, mike@sfphp.org. And then other sponsors tonight, we have like 5 books to raffle off from O'Reilly. So I forgot to hand out raffle tickets. We'll get that in a little bit here. And other than that, does anybody have any announcements about other community events or looking to be hired, looking to hire someone? Anyone? Yeah.
I've got 2 Zend certified engineer positions to fill. Anyone who's interested, or if you're interested in taking the CCD, looking for it, talk to you later.
All right, great. Yeah. Anyone else?
I work for Twilio. We're right over in Montgomery. We're also looking for a front-end engineer that has MySQL, JavaScript, HTML, CSS.
All right, cool. Well, with that, we're going to go and turn it over to Nick and Jon, and we'll go from there.
I think I'm starting. Hi. So, as Mike said, this is Nick Calugar. I'm Jon Tai. We work at IGN. And we recently attended ZendCon down in Santa Clara, right? Yeah. And they were talking about Zend Framework 2. And as pretty heavy users of Zend Framework 1, we were pretty excited about the new features and things that were coming up. So we decided to put together a talk on that. Hopefully get some of you guys excited about it as well. So a little bit of history for those of you who don't use Zend Framework. Zend Framework 1 was released in July 2007. They're currently up to 1.11. And as the numbering kind of suggests, it's kind of grown over time organically. So they've kind of added on modules and components and things. And consistency has probably suffered a little bit because of that. So Zend Framework 2 is kind of like a clean departure. There's no backwards compatibility issues to worry about. They're just kind of like starting fresh. And they've been talking about it for quite a while, at least a year. They've been doing like proposals and things like how do we want to redo the MVC? How do we want to do, how do we want to get things right this time? Matthew Wirafini has been blogging about a lot of things and they've been spending a lot of time with the design of it. So in October this year at ZendCon, they finally announced Beta 1, which is a working prototype of where they think this is going. And they kind of have these, is it weekly or bi-weekly meetings on IRC? And they kind of talk about, bi-weekly, yeah. And they kind of blog about where they're going, like the stability of the various modules and how things are shaping up and what they're doing on their blog there. So I've linked that. The plan is to basically have an incremental beta every 6 weeks or so. I think they're actually running a little bit behind with beta 2. It was due out like last week. But they're probably just kind of do the holidays and some modules that are like about to be merged but not quite ready yet. So they're holding a little bit. But the idea is to do it every 6 weeks. One departure is that the contributor's license agreement is no longer required for Zend Framework 2. They kind of decided that nowadays with open source being established as well as is, they didn't need that anymore. They've also moved their canonical repository into Git and over to GitHub. Previously, I think they were using SVN, and then they were hosting their own Git repository, but they moved over to GitHub. Distribution via Pyrus. So Pyrus is kind of like a new version of Pair, I guess, and the plan with ZF2 is to, in addition to downloading like the monolithic distribution, they're going to allow downloading like specific components that you want. So in ZF1 is kind of like, it's supposed to be an at-will framework. You can use various components, but you still kind of have to download the whole thing, and there's kind of like interdependencies that are not very explicitly stated. So this is going to change with ZF2. And ZF2 is going to require PHP 5.3 at a minimum, so it uses namespaces, it uses a lot of 5.3 specific features. So these are kind of the new features and concepts that we're going to cover tonight. We're not really going to dig too much into like nitty-gritty code because a lot of like the API and things are still changing as the betas go on. So we're just going to talk about high-level like kind of concepts and features that they're working on and kind of the discussion of how things are changing. The list there is dependency injection, the event manager, the new module system, new autoloaders, and some changes to the view layer and routing. So I'm going to hand it over to Nick to talk about dependency injection.
Thanks. By the way, there's going to be some links on throughout the slides. We're going to post the slides later, so don't feel like you have to scramble to write down the URL or anything. So first of all, who's heard of dependency injection? Okay, great. So dependency injection is very, very simple. It's exactly what it says. You want to inject your dependencies into your classes. So instead of creating, like with a new keyword or requesting dependencies, your dependencies are injected in. It's that simple. The other thing that dependency injection allows you to do is dictate how your application gets wired up, meaning how the different classes are configured to make your application. There are several different types of injection that you can use. There's constructor injection, which means that the dependencies are injected through the constructor. There's setter injection, meaning that you have various setters that set the dependencies. And then interface injection. Interface injection just means that your class can take a particular type of dependency through a setter, but it's defined by it implementing an interface that says, I'm going to set something in this class. So we'll get an example to make that one more clear. It's probably the most unclear out of those three. Okay, so just a real quick code sample. The first one here shows not dependency injection. So as you can see, a user's object is instantiated inside my class. That means that I'm stuck with that user's implementation. I can't change it at any time in the future. I've always got to use that very specific user's class. The bottom example shows how you would use dependency injection. This one is using a setter to inject a user's object into the class, and then later on I use it. Simple as that. So why would you use dependency injection? So the main thing is it enforces loose coupling. When you have an object that has been injected, it doesn't have to be of particular type. As long as it implements the correct interface, it'll work for you. The other reason would be it makes unit testing simpler. It creates, by using dependency injection, you have seams where you can put mocks into your objects so that you can mock out various like caches or logs or databases. Anything that you don't really need to test, it's not your system under test, you can inject mocks of these classes in by using dependency injection. Another point would be that it makes it easier to swap out implementations. For example, if you might be using MySQL as your database adapter, but say you're distributing your application and you want to be able to switch to a different database adapter. You can do that by using dependency injection. And another good use case would be to modify the default framework behavior. So now we're going to go into how they're doing dependency injection in Zend Framework 2. They basically implemented a dependency injection container. What this does is it handles object creation for you, and it allows you to, and the injection of dependency wiring. So basically the configuration of your objects and how they are dependent on each other. It keeps references to these objects created, so if you ask for an object it's going to keep a reference of that object. And if you ask for it again, it's going to return the reference to that object, not a new instance. We'll get into how you could do multiple instances a little bit. It also acts as a service locator. So basically, you can use it to ask for various things, whether it be objects, services, anything, any of your classes. Okay, so the next thing that ZendDI does is it has this thing called definitions. And definitions are basically the configuration for DI. The runtime definition. So this is the default if you don't do anything. You're going to get runtime definition. It uses reflection and can be hinted with annotations. So the problem with this is if you start running this in production, this is going to be very, very slow. It's going to have to do reflection over your whole library in order to discover all the dependencies, build up the definition list, and so on. So the next way you can use ZendDI is with compiler definition. And basically this just writes an array representing each of the components out to the file system. And then you include that file at runtime, and it loads very fast. And then the last thing is class definitions, and this is basically just hard coding a either XML, INI, or PHP file with your dependency injection definitions. And all of these can be used in conjunction, and they're added to a definition list. So you can use as many of each type as you like, and in the order you like. The next piece of ZendDI is the instance manager, and just like it sounds, it manages instances. Basically, this is the runtime information. This stores the instances that have been created by DI from the definitions. It supports parameters, and parameters are either dependencies, like what type of object do I need to inject into this class to make it work, or configuration values. Configuration values would be like a username and password for a database, things of that sort. Preferences. So this is an interesting one. If your definition calls for an interface, that doesn't tell you what concrete type you want to use in this particular case. So having a preference says, okay, this class requires a certain type of interface to be injected, but in this case, I'm going to inject this concrete type. In another case, I'm going to inject a different concrete type. So that's what preferences means. Aliases. Aliases are just simple names for your classes. The first time I saw this, they used it, an example was the various controller names in Zend Framework 2, and they aliased them so they weren't so long. Another example of that would be if you have multiple instances of the same class. So say you have two databases you want to connect to. They're both going to use the same exact DB adapter. However, they're going to be configured differently, and in order to ask for them from DI, you have to provide an alias and say, okay, I want this database adapter or this database adapter. And then, so here's an example of everything I just talked about all in one slide. So the first thing you'll see is that the class implements ViewAware. So that's an example of interface, using interface for DI. Then the constructor says, okay, I need to take a database, meaning that DI can use that information just in a constructor and say, okay, I know this class takes a database. The third set here is a setter injection, and DI can figure out that, okay, this class, oh, I'm sorry, there's an annotation here called that says @DI inject, and that tells ZendDI to look at this setter and say, okay, you need to have a service, instance of service injected in this class. The setView method is to satisfy the fact that this class implements the ViewAware, and then you can see down below there's the ViewAware interface, which says I need to implement the setView method. So optional versus required meaning. Yeah, go ahead.
So by default, like for the setter, like you may just have like a set method on your class, and ZendDI, like when it goes over the reflection, it doesn't think that every setter is like a mandatory dependency. So it'll just say, okay, well, that's a setter. I'm going to ignore it. That's why the annotation is required. So you basically say, no, 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 I really need this dependency in order for my class to run. So even though it's a setter method, like please treat it as a mandatory dependency. With a constructor dependency or an interface interface injection, it's basically like known that you need this thing because otherwise you wouldn't have gone through the trouble of creating the interface. And with the constructor, you can't even make the object without it. So it's very obvious that those things are required. But the annotation is required on the plain setter. You don't have to use annotations if you don't want to. So if you were using, what was it, class definition? So if you configured like outright like all of your dependencies in some INI file or something like that, then you wouldn't need the annotation. It would just figure out, okay, well, you said that was mandatory, so I'm going to do it.
Does anybody have any questions at this point? I think that's the last slide on DI. Crystal. Nice. Oh, go for it.
What do you think is the greatest advantage of using DI compared to how it works now?
Personally, I'm a big fan of separation of concerns. I think that's the whole mantra of DI is your class should only do what it's concerned with and inject all other responsibilities into that class. I think it just promotes really good design. So, you have a comment on that?
My favorite is testability.
Okay, so here's just a few links. Dependency injection is a very popular topic on the interwebs. Search around for it. You've got Mr. Patterns, Martin Fowler here. Ralph Schindler is the Zend Framework developer that worked on ZendDI. So he's got a lot out there. And then the last link there is the API documentation for ZendDI. But this is a very well documented academic subject on the internet. So I encourage you to do some digging. So that tells, let me go back a few slides actually. That tells the runtime definition that you want something to be injected into that using that setter method. So that setter method doesn't get called automatically when you instantiate that object, but if you ask for that object from DI, if the runtime definition has already looked at it and said, oh, I need to make sure that when I construct this class, the next thing I'm going to do is call that other setter, passing in something else from DI as well. No, you ask DI for it. Yeah, I guess we kind of missed that part. Yeah.
Well, you either ask DI for it, in which case it's acting as a service locator, or it was injected into your class as a dependency. So if you've got one class and it has one other class, you're not really going to use DI. But if you're wiring up a complex application, you look at a typical web application, you got your controller, you might have your view, you might have some services, you got a database, you got all these things. And so pretty soon, you've got some part of your controller that's new this, new that, new this, new that. And then you kind of end up in a mess when you go to testing, or if you want to swap out some component functionality or something like that. So DI lets you do kind of all this stuff in something else in a system that's designed for that, which is DI, and you can configure that, or you can, that likely it goes into some INI file in your application, or you compile the definitions or whatever. But basically that takes the responsibility of that outside of the actual class. So when you have complex, if you've got something that has a dependency, and then that in turn is a dependency for something else, you might have a database, gateway class, and then it in turn requires an adapter class, and then your controller requires that database class. All of that can be managed with DI. So all you do in your controller is say, hey, I need a database class. And it automatically knows, okay, well, to make a database class, I need a database adapter. And to make a database adapter, I need these parameters in the config file and these other classes, inject all that stuff. So in the end, your controller is very, very simple. It just says, inject into me a database. And that's it. Yeah, so that's an annotation. like I said, this isn't the only way you can specify that. You can specify that by config, like in a config file separate from your class. I personally like annotation because it keeps the method with the fact that it needs, it needs to be called together, as opposed to you write some class over here and then you've got some config file over there and then you need to keep the two in sync. So if you're using runtime definition, then on the fly, it'll parse, it'll use, PHP will use reflection to, figure out what the comment is, and it'll parse the comment for that annotation, and then it'll, affect the behavior. Or if you're using the compiler definition, when you compile your definitions, it'll use runtime to, grab that and then save it to an array. So I think there are other frameworks that use, Symfony uses annotations for quite a bit of stuff, right? With like the ORM and stuff.
Doctrine does as well. So, if you're used to any of those other, like a great example that probably everybody here is familiar with is like PHP doc. All those fancy symbols don't mean anything in comments. It's made for a reflection engine to parse and turn into HTML in the case of PHP doc, or in ZendDI's case, turn into a DI configuration.
Does that answer the question, or?
Yeah, pretty much. I'm just kind of wondering why. I guess, but I think
It's just parsable. It's parsable by the reflection engine for ZendDI. Yeah.
Seems to me that this is good for your logger, your database adapter, things like that, but it doesn't help at all with your models. Is that true? I wouldn't use this to get a user model just because it's all about right.
The question was that it's good for like database adapters and loggers and stuff, but not for your models. Why? I don't.
It's only good for something I could use as a single.
Okay, so you're saying if you had like an active record kind of pattern where you have multiple user objects that are sitting around that you, yeah, I think that's probably true. I mean, you'd probably get an instance of your user model like created somehow, like maybe your database class returns it or something like that, or or your cache. Yeah, exactly. So you'd have like a user factory that gets injected as a dependency, and then you'd ask a user factory for it. So yeah. Okay.
Moving on.
Sure. Okay, so I'm going to talk about the event manager. So there's, and this is like completely ripped off from the new API documentation. So there's 3 use cases for the event manager. One is kind of simple subject observer. You could do aspect-oriented designs or event-driven architectures. I think an example of like the event-driven architecture is that the new Zend Framework 2 MVC, like the old one was very like, hard-coded, this calls that, calls that. In Zend Framework 2, the whole MVC kind of system is event-driven. Like a couple events get fired, and you happen to have listeners that listen to those events, and and then that's what calls your controller, and that's what renders the view, and so on. So and I'll talk more about it later. There's several places in Zend Framework 2 now which very much rely on the new event system. At its core, it's pretty simple to use. So if you want to use the event manager yourself, you can basically compose an event manager into a class, and then you just, somewhere in your class, you trigger things. So if you had, for us, we used it for a service class, like a service call wrapper kind of class. So we basically, have the event manager inside this service class, and then before we go make the HTTP call, we fire an event that says, http.pre, and then after we make the call, we fire a post, or if there was an error, we fire like an error event or whatever. There's a couple things. There's like the event name. A lot of times you'll just use the function that you're in when you trigger that event as the event name. I mean, you can override it, but a lot of times that's appropriate. There's also a context that you can do with events. I think this is very jQuery-like actually. So you usually pass the class itself as the context, and then there's some arguments that you can use. And then finally, you have to have something that listens to that event. Otherwise, it's like, okay, you fired an event, nobody cares. So you can basically attach, usually classes that fire events will have methods that say, okay, here's how you subscribe to it, and so on. So those usually get proxied to the event manager, and then the event manager will make sure to call back all your listeners when the event is triggered. So there's a couple other advanced features with the event manager that are pretty nice. So when you when you register a listener with the event manager, you can specify a priority. So by default, it'll just use, I think it's like 0 or something like that. But you can basically use, positive or negative integers to say, okay, well, I want mine to run first and I want mine to run later. There's also a concept of a static event manager. So like, let's say you wanted to, let's say you're doing some like debugging thing, like so you have some debugger class that you want to hook into like every event in the system. I guess that's not really, because it doesn't allow you to do that. But let's say you want to hook into like the name, you know the name of the event already, you know the name of the class that you want to hook into, but you don't have an instance of that class yet because maybe DI hasn't run or you're still in the bootstrap phase or something like that. You can use the static event manager to basically say, okay, here's like a name already that I know that is going to exist later, and then when that actually, gets instantiated and the event actually gets triggered, then you'll get your callback. So it's kind of nice that you don't have to already have an instance of the object before you can register for events of that object. You can short circuit execution of an event. So the event listeners basically can return a value. So like it's a callback function, and then you can return something. And I think you also get past the event, like an event object, so you can call like stop on the event or something like that to basically stop execution of an event. I think they use this in the MVC in their like error handling plugin, basically. Like, so if an exception is thrown, then basically it goes to that thing and then it basically stops, any other further view rendering because it's already rendered the exception and so on. So you can, it's up to the event triggering class to say, okay, well, here, trigger this event, call all your listeners, and then if some condition is reached, depending on what you want to make that, then you can stop execution. And then also, after you've stopped execution, you can basically go back and say, okay, for all of the ones, or if you don't stop execution, it just stops on its own because it's out of listeners. You can basically go back and say, okay, what did each of my listeners return? So you can use that to, farm out like a calculation or something to a bunch of different classes and then basically get all the results and gather them up. So the features that are provided lend themselves to like a lot of different use cases, not just like implementing MVC or something like that. You can implement like a plugin system that way, like hook into events and basically, fire off plugin hooks and stuff like that. So here's an example. So you have some class, and it has an event collection, which is the event manager. That's not true.
The function events basically returns
The collection. Right. Okay. So that's where you create the event manager. If there isn't one already, you could have the event manager injected, but typically every class is supposed to have its own event manager. Otherwise, when you trigger an event, then it starts like firing from some other class, which is kind of weird. So a lot of times you'll see this pattern where you're kind of, and this is in ZF1 a lot too, is where you'll just like, okay, well, if I don't have one yet, I'll make one. And then the bar function basically is triggering a event on that event manager. So then you'll have a listener class that basically says, okay, well, I want to attach to that bar event, and and you're using a closure here, which is a new 5.3 feature. So yeah, you can give like a function name, any sort of callback that the PHP callback type. In this case, it's a closure. So it's saying, okay, well, when the bar event gets triggered, then this is what handles that, and it's being passed an event object, and then so you can get some properties from the event object and so on. So like I said before, the MVC definitely is using events to do its routing and dispatch. So when it does its routing, it just fires off a route event. And then when it does its dispatch, it fires off a dispatch event. The fact that a controller gets called and a view gets rendered and all of that stuff is really just a listener that implements those things. This makes it really nice because in Zend Framework 1, if you wanted to override parts of the MVC, it was really, really difficult because like to inject a dispatcher, you had to like kind of dissect the whole thing and then kind of like shove this thing in here. Now it's a lot easier because it's just an event. So if you want to override some part of the MVC, you just say, okay, don't listen the default listener, don't listen, and then you make your own listener that listens to the event, and then you're good. The core kind of stays intact. So I think it helps a lot with the separation of concerns. Another thing that's using it is the new module manager, and Nick's going to talk about that some more. But basically, whenever modules get initialized, an event just gets triggered, and then it's up to the module to say, okay, on init, I want to do these tasks, or when I get my config and stuff like that, this is what happens. I think they're going to, as they continue to refactor Zend Framework 2 components from Zend Framework 1 components, they're probably going to use this more and more. So it's a good paradigm to get used to. Are there any questions on EventManager?
Sorry, I snuck in that closure thing on you. Did everybody see that? So if you're not really familiar with PHP 5.3 yet, so there's some new PHP 5.3 goodness there. Instead of using a normal like callback statement that you're used to in PHP 5.2 and under, you can pass a function in, anonymous function in, and one of the coolest things here is it's using the use keyword, which says, okay, I'm going to use something that I instantiate out here inside my anonymous function. So, slick. Good?
Yep.
Okay, modules. So if you use modules in Zend Framework 1, you're probably highly disappointed, like me. They're just very unruly. They were never given like first-class citizen attention. They were just kind of slapped on. So the new module system is night and day from Zend Framework 1. It's designed for flexibility, simplicity, and reusability. Your modules can contain anything, and this wasn't the case before. Obviously, you're going to have PHP code in there, but now you can have view scripts, public assets like your CSS, your JavaScript, things like that, and your tests, all included in a nice module package. The most basic module is just module.php. You can literally implement an empty class, and Zend Framework 2 will load that as a module. The next thing you'll need to be aware of is the module manager. Its job is to discover modules. It's going to basically loop through whatever you've configured, the directories you've configured, finding modules to load. It also calls these 3 methods on every module.php. The init method. I'm going to say this like 4 times probably, but it's very important to do minimal lightweight tasks. About the only thing you're going to want to do in the init method is like register a listener maybe. And yeah, I'm just going to leave it at that. Get config. Basically your environment string is going to be passed in, so production, development, staging, testing. Your environment's passed in, and it wants back a config, ZendConfig config object. This is going to be merged into the rest of the application configuration. So as it's initting and getting config of all these modules, they're going to be combined and merged together. So you're going to end up with one big configuration object. They're actually working on something right now. Something they didn't do a lot of in Zend Framework 1 is they're going to allow an automatic caching of this configuration object in Zend Framework 2. That's around the corner. The last thing is get autoloader config. If you download beta 1, you're not going to see this. This is going to be in beta 2. They kind of left autoloader stuff up to you in the beta 1, but they're kind of reeling this in. And this is also an effort to be able to cache the autoloader configuration. Your module, in this case, it's a little bit different than init and get config. Your module must implement autoloader provider, and you need to return an array or an instance of a traversable. And all these, so another change from beta 1 and the new coming beta 2 is that all these are going to be implemented with listeners. So this is where more things are coming with the event manager.
One thing really quick, I think we left this off on the slide. The actual like MVC skeleton where it calls like the controller and like it renders a view and all of that stuff is actually in a module. Like that's not actually built into Zend Framework. That's in a module called the application module. So really everything now is a module, and if you don't like the way that they do their MVC, you write your own application module. really the module manager is all you get. And you get, I think it's a boot, so it calls init on you, and then it gives you a bootstrap event. So all you're supposed to do in init is register for this bootstrap event, and then wait until you actually get that event to do the rest of your configuration. The reason you want to keep inits very, very lightweight is because all of your modules are going to be loaded, and all of them are going to have a init called on them. But if you do like a ton of configuration and a ton of setup and object instantiation, database connections, and who knows whatever in init, your application is going to be really slow. But if you use it as it's intended, which is just register that very simple event callback and then do all your stuff later, then it's going to work as intended and actually be pretty performant.
That's a really good point. So they not only provide you, you can get the Zend Framework 2, the entire library, but they're also publishing a Zend, a module that you drop into your application that is basically your skeleton module, and that's what gets you started. It provides the default functionality, and it gives you a great jumping off point to start developing your application. So that's on their GitHub as well, and they're going to continue to update that as new features are new features are made and APIs still changing. So just some quick tips on the lightweight modules. You can register a single path, multiple paths, or explicit paths. So a single path would be like, okay, in my application, there's a modules directory. Every single module is going to be in there. Multiple paths would be, say you had your core set of modules, and then you had your modules developed internally at your company, and then you had another folder for third-party modules. Just a way to organize code. And then explicit paths would be a path somewhere else in your file system. Say a module developer decided to publish their module with pair, and you installed it with pair. You can do explicit path and tell it, okay, go find this module. It's where I installed all my pair stuff. So that's just a couple ways you can do it. Modules can be packaged with FAR or simply TARD. So you can just throw the third-party FAR file in there, or package your own module up as a FAR file and distribute it, and people can just drop it into their Zend Framework 2 application. Here's the fourth time, keeping it lightweight. Seriously, keep it lightweight. The module should never write to its directory. So what that means is that when you give somebody a module, don't expect them to 777 on a directory inside that module. The module should stay intact, untouched, completely the same every time they install this. They should be able to take your module, delete it, and install a new version. There's some talk about them writing some installation stuff, but that's not for sure. But anyway, the point is, don't depend on that being writable at any time. The way you'd want to do writable paths is you can do overrides in your main application. So once your module has been initialized, you can listen for an event and then configure it to tell it where the writable location is. Coming up soon is they're going to establish, basically, if you're familiar with star Nix conventions, they're going to have a confd directory in your application where you can put files that will be read by the Zend Framework 2 application, and that will be used to override all the defaults for not only your application, but all the modules you installed. So basically what they did was they released beta 1. They wanted people to play with it, and now they're getting a lot of input, a lot of feedback as to how it's working. And so everything that's happening right now is because of people using it and giving feedback. So go out and play, and you'll get your wishes right now. Use a vendor prefix. So the reason they say use a vendor prefix is that there's going to be 30 people out there making a video module, but ours is the IGN video module. So that way people can install both of them, play with them, use them both at the same time.
Actually, single path versus multiple path, one thing that changed recently and will be for beta 2 is that instead of just a modules directory, now they have a vendor directory as well. And that's where you're supposed to put your third-party modules.
Okay, that was modules. Anybody have any questions on modules? Let's see. Okay, so I'm kind of hinting at how it's implemented under the hood. You don't really have to if you want to, you can dig in and see how it works. But basically, all these methods will end up getting called on your module.php file. The only one that's slightly weird is the autoloader one, and in that case, you have to implement autoloader provider, or else it won't call it on you. Like the init says, like if function exists, call it. I think same with the get config, but the autoloader one's slightly different.
What? Dependency injection happens after. Let me clarify about the events. Basically, the module manager itself just fires an event, and then it itself has other listeners that call these methods. So it has a listener that says init the module. It has another event or another listener that says go get the config for the modules and stuff like that. So we were just trying to emphasize that even the module manager itself is very event driven under the hood. And so if you don't like get config, you want to call it get configuration or something, you're free to implement your own listener, deregister to default one, and then get your config your own way. That's kind of one of the things is they try to be like very, very flexible and very accommodating. If you want to override parts of Zend Framework functionality, you can do it. That's all that was. In terms of autoloader versus getConfig is like an array that has config specific data about your module. The autoloader is one that was a little bit contentious because some people were like, well, what if I have a module that just has some CSS files and like some view scripts? Like I've got no classes. I don't want an autoloader. I don't want to have to provide you one. There was also a little bit of issue with like if every module returned its own autoloader, then your SPL autoload register stack gets very big because if you have like 50 modules, then you now have 50 autoloaders that are registered and they'll be called in order, which is not very performant. So what they decided was, okay, well, we'll compromise. If your module is Zend Framework aware, then you can implement this interface and basically return like a part of an autoloader like config, and then it'll be merged in with the main autoloader that already exists. But if your module is like not a Zend aware module, like you might just grab some pair library or something like that, then you don't have to implement that interface and it won't call that method, and you can just register your own autoloader, or you maybe already statically loaded everything ahead of time or whatever. So they tried to satisfy and keep the lowest common denominator very, very, very low. Yes.
So Zend Framework 1, the way they do a lot of the module stuff, it's very tied into the Zend application and the Zend controllers and all that. With these new modules, is it easier to take a module and use it outside of that full Zend application? Or kind of sharing with another something?
Yeah, they're gunning for third-party modules to proliferate around this community so that you can go and take anybody's module and drop it in your application. It should run. That's the goal. We'll see how it plays out. It's going to take well-written modules to do that, but that's how it's supposed to work.
Yeah, but the opposite, I think what you're asking, Mike, is the opposite. Like, can you take something that works in a Zend Framework application and reuse it elsewhere? And I think they're aiming for that as well. That's why they're keeping the requirements kind of low. So you can write code that's kind of like not very Zend-y, and it'll still work. Like, it's not tied in so heavily. Like, I'll talk about it more in the autoloader stuff, but yeah.
Question about where DI comes into play is normally you're not going to end up using DI until you get into your controller, or if you're listening to an event after all the modules have been loaded, something like that.
Yeah, Module Manager gets run very early. Once Module Manager is done merging all of those configurations, now it has the final configuration for the application, and at that point it triggers the Bootstrap event. And so once you get the Bootstrap event, then DI has its configuration and can go do DI. So while you're still getting your config and stuff like that, you can't use DI because you don't have all the definitions configured yet.
Cool.
Okay. So autoloading. Autoloading is something that's probably a little bit overcomplicated in ZF1, I think. And they kind of aimed to simplify that in ZF2. Well, I'll tell you what that last line says. So the new autoloaders, basically, they got rid of the singleton, so there's no more Zend loader autoloader singleton that you have to, have around. Now you basically have just an instance of an autoloader, and it registers itself with SPL autoloader register. And each autoloader is self-contained, and there's multiple implementations of autoloaders that do different things. So before, like I said, your Zend loader autoloader required Zend loader to actually do the class loading work. Now everything is just in one of these implementations. So they provide 2 implementations along with like some interfaces and some helpers and stuff like that. But the main two classes are standard autoloader and class map autoloader. So the standard autoloader basically takes namespace and path pairs. This is a little bit more clever than the current implementation, which relies on the include path. So if you say, okay, all of my Zend prefixed classes are here, then it won't search the include path. It'll just say, okay, I'm going to look in this directory, and if I can't find your Zend whatever class, then I'm going to give up. It's not going to go and just say, okay, include Zend whatever, and then have PHP search the include path for all this stuff. You can configure it as a fallback autoloader, so you can basically say, well, I don't know where all my stuff is organized, so here's a couple paths to search, or just use the include path or whatever, and go. And then basically it acts exactly like the Zend Framework 1 autoloader. The more interesting autoloader in my mind is the class map autoloader. So what the class map autoloader does is basically it takes a file, a hash of class name to absolute path pairs. And you would generate this, like you wouldn't really want to maintain it by hand if you have a lot of classes, but you generate this like at build time or deployment time, and then you probably do it 1 per component. So if you had like modules, so every module probably provides its own class map. And then what those, you kind of incrementally add them to this class map autoloader. So you have one instance of autoloader, you say, okay, add these maps, add these maps, add these maps. So what the autoloader ends up with is like a giant hash of every single class that exists in your application and the absolute path of where to find that. And what that last line says is fastest autoloader implementation. Matthew Wirofini basically did some benchmarks and said, okay, I'm going to try out some different autoloader implementations or strategies from various frameworks and things like that. And he basically came up with, okay, class map autoloader is like the absolute fastest because it avoids pretty much any sort of statting on the file system. Like there's no like test if this file exists at all. All it does is look in the hash and say, okay, is this class in the hash? If so, instantiate it and return it, return it after you load the file. And then if it's not in the hash, then it just doesn't exist, period. It doesn't try to go search for it or do any sort of hunting. I think he said, he gave a couple different numbers in a couple different places, actually, so he might have done a couple round of benchmarking. I think for us, there's a backport. He actually backported the ZF2 autoloaders to be, I think, PHP 5.2 compatible, and also made it Zend Framework 1 compatible. And so some people have been using this new autoloader in their ZF1 applications. I tried to do it just experimentally, and I think we saw something like 15% performance gain just for autoloading, which is not too bad. So yeah, any questions on autoloading? Yeah.
You mentioned that it avoids the include path. How does it do that?
The class map autoloader or the first one, the standard?
You said it avoids the PHP include path.
Yeah, so the standard autoloader avoids the include path because you can, if it's not acting as a fallback autoloader, and you're actually registering like specific things. Like typically what you'll do is you'll have your library and then Zend will have its library, right? So you're using Zend Framework. So you basically configure it with 2 directories. You say, okay, anything that starts with Zend, go look in this directory. And then anything that starts with IGN, go look in this other directory. So then it doesn't have to, I think actually as a fallback, as a third one, it might search the include path. But if your thing is Zend, it will never look for it in the IGN directory, right?
It goes based on the class name. Like,
It goes on the prefix, yeah. So you can, if you're using 5.3, then you use a namespace. And then if you're using the backported ones, then you can use a prefix. So like Zend _*.
actually, another question about modules. They sound similar to Symfony's bundles, Symfony's bundles. They seem pretty similar to that. And one thing that is in the Symfony 2 community is really pushing kind of repository bundles. Have you guys heard any talk at the conference about some kind of public repository hosted by Zend?
Yeah,
Kind of like jQuery plugins.
yeah.
Other things where people can distribute modules.
Yeah, so the question is there like a repository for modules? And the guy who wrote the module manager, Evan Curry, is actually really looking forward to that. Like he wants, as Nick mentioned, he wants like a vibrant community of modules, being written and shared and improved upon. So I don't remember the exact URL, but I think he bought something like zenmodules.com or something. I don't remember the exact URL, but he bought something and he worked with Zend. I think they're actually hosting it for him now. And so they're kind of playing with that. I don't think any official announcement has been made, but I haven't been following IRC for the last few weeks. So I think they're definitely going in that direction, but there isn't anything, quite there yet.
Was there any talk about packaging modules in such a way that you have some kind of metadata that you can distribute with it? Version numbers, or like say you put in an author and stuff like that. Say some sort of like readme or info.
Yeah, as far as package metadata, I mean, I don't think there's anything, I haven't seen any discussion of anything very formal like, an XML file that says, everything about your module. I think there was some stuff in the code for the module manager about dependencies, but I didn't look into that too much because we weren't using it. Like, we were just kind of playing around with it. Yeah, it's probably still a work in progress, but I think the work in progress that I've seen is focused around dependency. It's not even dependency resolution. It's more like dependency checking. Like, hey, my module requires, this PHP extension or whatever, so you don't have it, so I can't load or whatever. I didn't see too much around, author metadata and that sort of thing. Okay.
I'll just say one more thing about the class map autoloader. My first reaction is, you have all these PHP files that are generated with this big array, and it sounds kind of slow off the top of your head, but one thing to note is that since they're PHP files, that they're going to get cached by APC. So once all these files have been read once by your production application, that's going to be read very fast, and you're going to get performant autoloading. Okay, so the view layer, this is really simple. It's just a convenience API. It's a slight change from Zend Framework 1. So what they're doing is they're going to extract all your view variables right before you render. And all that does is say, instead of this foo, you can just say $foo now. So your variables are in the same scope as your view scripts now. This foo is still available. And one thing to note is that all scalar values are escape by default. So you don't need to call escape if you've got a string that's been passed to your view. You can just echo it. You still need to escape things like, say you've got an object that has been passed to your view. If your object contains a string, you still need to make sure to escape that. Or if you're echoing a array index, the array value, you still have to escape that. You can get the raw version. Say you've got some sort of HTML snippet. You can say this raw in the key, and it will return the unescaped version. Here's a link to, I believe that link is...
It was actually, I couldn't find a proposal for this, or I couldn't find an up-to-date proposal for this. It seemed like the proposal had gotten pretty far out of date with the implementation. That link is actually one of the developer updates that says like, okay, this is where we're going with it and so on. But he actually goes through the syntax for it, so that was the most useful link I found. The other useful thing is to just check out the source for the view. It's pretty small and simple, so if you just want to check it out. It's called PHP Renderer now, so it's in Zend View namespace, but it's PHP Renderer as the class.
And just a quick example for what we just went over. $name, it has been extracted and also escaped for us already, so we can just echo it. Avatar HTML, we don't want to escape it because we know we've already got that HTML escape for us. The messages count is a function call on an object, some sort of collection. So we have to escape that before we echo it. And then when we loop through each of the messages in that collection, since the renderer can't escape that for us, then we have to escape each of those as we loop through that collection. So any questions on the view? Pretty straightforward. Cool.
Okay, and the last topic is routing. So routing has been completely redone, and actually as of beta 1, it wasn't quite working. So if you download beta 1, there's some sharp edges there. In beta 2, I saw on some IRC log that it's more or less complete, so you probably wanted to wait till beta 2 before you play with some of the stuff that we're talking about here. With the new routing system, your basic unit is a route, and it basically accepts a request, and then it returns a route match object. So within your route implementation, you can basically do whatever you want with that request. You can look at, what the URI is, which is what you're typically going to do, but you could look at like the host name, you could check for, random headers, you could do whatever you want. So a route stack is an interface that extends the route interface and basically aggregates routes. So there's some methods that they add, like add routes and I think get routes and stuff like that. So basically, a route stack both acts as a route by itself, but then also is a container for multiple routes. The way that it resolves like which one you actually meant is up to the implementation. So there are two implementations. One is a simple route stack, which is pretty much the Zend Framework 1 behavior, where you're basically iterating all the routes in order. So if you have a simple route stack and you register 18 routes with it, it's just going to, for every request, say, okay, start with the first one. Do you match? No. Do you match? No. Do you match? No. Okay, I found one that matches, return, whatever. The more interesting one is tree route stack. And this is implemented, this is an interface, so then the actual implementation, there's one called the part route. And what it does is it basically breaks up the request part of request URI and says, okay, for every slash, look at the piece and then match. Actually, I don't think it even breaks it up by slashes. It basically says, okay, match your piece. And then once you've matched a piece of the route, then you have other sub-child routes that then can match other pieces. So I'll show you an example in a second that's kind of difficult to understand. There's some API documentation. There's a link down here. So the example that I kind of came up with was if you have a URL like this where you have uk.ign.com and then you have wikis and then you have like the name of a wiki, in this case Skyrim, and then you have an edit, which is like your action, and then like the name of the page, the name of the wiki page. So your tree might be set up something like blogs, wikis, videos, like high level stuff, and these trees, I guess, would be contributed by modules. So you'd have like a blog module, you'd have like a wiki module, you'd have a video module that basically say, okay, my top level route is wikis, and if you match that, then worry about all the other routes that I'm gonna give you. But if you don't match wikis, then there's no point in matching all of the other routes that I have to give you because it's never gonna match. So once you've matched wikis, then within that top level route, this tree route, you basically specify sub-routes. So in there, you can say, okay, well, I have a route that's more or less the traditional routes where it's like the name of your wiki /new or the name of your wiki /edit, or you might have delete or lock or whatever, and then that would match, and then your colon wiki or your colon page would then get passed as parameters to whatever controller it ends up calling. And then you can also have other routes. So I think by default now they include a host route, which actually doesn't match the path at all. It just matches the host name. So you could then say, further down the tree, you could say, okay, now that we know that we're editing some wiki page, let's look at what host you actually matched, because we might return the UK version of this versus the US version or whatever. It's sort of a contrived example. I tried to incorporate as many of the routing features as possible, but I think the point is that routing has become much, much more flexible and performant at the same time. So I'm pretty excited about this, especially at IGN, because we have lots and lots and lots of routes. So this should help us a lot. Any questions on the routing piece? Okay. So I think at this point we'll open it up for general questions. Did you have anything to add to the? Okay. So
we can take general questions, and also if you have any questions about IGN, fire away. Using a framework at all, the ramp up time to writing a new application, you'd have to write a whole lot of code to get an application running. So I mean, unless you're like somebody like Facebook where you can't afford the performance hit from a framework, get out to your users as quick as possible. I think that's what a framework provides. As far as which framework to choose, try them. Find the one that has the features you like. I happen to stumble into Zend Framework first, and I haven't hit a roadblock with it yet. I really enjoy working with it. I'm sure Symfony would be just as good for my use case. I don't know the other ones as well, but
as far as not using a framework, I think if you're going to invest, you're going to have to invest some time at the start of your project. So you either invest that time writing your own framework, essentially, because you need something to handle some of the basics, sessions and whatever. So you can either spend that time doing it yourself and then really have nothing besides your project. You have nothing else to show for it. Like, you can't go and then work on some other project that's using some other standard framework because you don't know anything about the framework. Or you could pick a framework and then now you know something about that framework, and your ramp up time for your next project is greatly reduced. So I think using a framework versus not is pretty much a no-brainer. As far as which framework to choose, the reason I like Zend Framework a lot, I've tried a couple other ones before that. The reason I like Zend Framework so much is because of the at-will architecture of it. Like, Zend Framework doesn't force you to use the MVC component. It doesn't force you to use the forms. It doesn't force you to use all this stuff. There are a lot of loosely coupled components that happen to work very well together. So if you're like, oh, well, suddenly I need to authenticate against an LDAP store, ta-da, there's a module. You just include it, and it works with your existing configuration. It works with your existing session. Everything plugs in nicely, and you're good to go. I found that with some other frameworks, it's like, okay, well, I have to do everything their way, and now I want something slightly different, and it's very hard for me to, swap it out with something else. Zend Framework, I think, puts a very, very big emphasis on, you might not want to do it our way, you can swap it out for something else. So that's my personal plug for Zend Framework, I guess.
Yeah, they call it an MVC framework, and Zend has never given us a model layer, and they might give us some options in the near future. They're considering using something like Doctrine, but like John said, it's kind of use at will. And another point I'd like to make about using a framework versus not using a framework is, for me, it really made me a better developer, looking at how the different frameworks write their code and organize code. So that's another bonus there.
In ZF2?
They don't. I think that's on purpose. Yeah, it's on purpose. So give me an example of a controller plugin. Give me an example of a controller plugin like.
So for the
I think it's just listen to the events now.
Yeah. So for the controller plugins that have like life cycle, like where you're hooking into pre-dispatch or post-route or something like that, events basically is the way to go. You register your own event listener and you hook into that event, and so that basically gets you those hooks. Actually, that's all that controller plugins.
Yeah, so
provide,
it's
right?
going to be in your application module. You're going to have to make an error controller just like before, but you're going to have to figure out at what point in the life cycle of the application you're going to listen and register that. So your application module would, during its initialization.
Yeah, and like I said, the the error handler one, they do have one, and it comes with the skeleton application in the application module, but it's not anywhere in Zend Framework itself. Yes.
Yeah, I don't know if I misheard, but it sounded like in the beginning of the conversation today, you guys mentioned that ZF2 is going to be 100% backwards compatible.
No, I said it's not. No, I said that basically they're taking this chance to totally throw away backwards compatibility. I think actually, having said that, I think just kind of as a, I wonder if this would work, Matt tried to write a backwards compatibility kind of like layer using the new MVC stuff. So he basically wrote event listeners that called the same sort of, things that you would, do in a Zend Framework 1 application. I don't think the goal, from what I, read, the tone seems to be that it's not meant to be like here's a drop-in solution so you can upgrade to ZF2. It's more like, hey, our stuff is so flexible, we can implement ZF1, like kind of thing. So I I don't know how it's going to shape out. They're still changing the MVC a little bit. Like beta 2 is going to be a little bit different than beta 1. I don't know how different beta 3 is going to be from beta 2. So I think it's still a little bit early to tell just how backwards compatible it is going to be.
Yeah, when do we expect to be able to see like an actual production release?
So at ZendCon, it was, we're going to drop a beta every 6 weeks, and we're going to keep doing that until it's done.
So like 20.
Your guess is as good as mine. I think Matt was shooting for like sometime middle-ish of next year, but who knows?
I think I don't think you're going to need to. Well, they're not going to tell you to run it in production until the official release comes out. If you're a gunslinger, I mean, we did it in a week. We hooked it up in a week. We wouldn't run our production code on it, but we're thinking about it.
Also, I think there's a difference of scope as well. They basically have had some discussions in some meetings on IRC about what constitutes like a 2.0 release. I don't think they're shooting for like all of the modules in ZF1. So they're not. It's not going to be like, okay, here's all the modules in ZF1, and we're going to have all those in ZF2. I think they're basically going to say, okay, ZF2 now contains a refactored cache and log and database layer and MVC, and that's good enough. We're done. And then as people need other things, they'll kind of port them over, and it'll grow. But the 2.0 is probably not going to be as fully featured as ZF1 was.
So I realize that this really depends on specific instances, but in your experience specifically, what percentage of your code would you say you had to rewrite to migrate from ZF1 to 2?
Most of it. I don't know. We didn't try to port direct. The only thing we tried to port directly was a controller, and in that that worked.
I think.
One big change between controllers though is instead of setting stuff on the view, you return stuff from your action, which is much cleaner. It makes it more testable actually. So, yeah, you can't just take an old plugin, like you mentioned. You can't just take an old plugin and throw it in there.
I think it depends a little bit on whether you just want your stuff to work in ZF2 or you want your new application to be a ZF2 application. Like, Nick's wearing a Hack Week shirt. Actually, I am too, but I have a sweater over it. So what happened was, as it worked out, when we got back from ZendCon, IGN does this Hack Week thing where we basically have a week to do whatever project we want. And we were super excited about ZF2. And we're like, all right, let's try to port our application to ZF2 and see how far we get. So basically, to be a ZF2 application, we kind of had to redesign a lot of our components to take advantage of like the EventManager. Like for example, we had a service class before that would make service calls to various external services, Twitter or whatever. And that thing used to have like logging and caching and like everything built into this one monolithic service class. Well, with the new EventManager, we're like, hey, we can implement that as event listeners, and we'll just have a very lightweight thing that does the HTTP call and then fire events before and after it. So if you want to do that level of refactoring, it's like, well, I don't know, how good are you? But if you just want to get it to work, you could probably grab their backwards compatibility layer or whatever and kind of massage things until you don't get a white page anymore. All right, it's pretty quiet. So Mike?